We should be good. All right. So, today is going to be the last update on the Ant CNC PCB mill for a while. Essentially, all the main steps are now complete, and there's only small things that need to be changed around to finish the build for real. So, the first thing that was to be done from the last update was the electronics assembly, which essentially is the whole taking all the cables that were prepared, putting the controller boards together. So the Nucleo 401RE and the CNC Shield V3 together with the stepper motor drivers, connecting all the cables together, get everything nice and neatly organized as much as possible. That was for the most part very fairly simple. So I decided to do another step during that day and actually finish the preparation for the bed. So now the bed is complete. There's nothing else to do for it. And there are still two things missing because I have yet to receive the main power switch, which I thought I had a replacement for. But that replacement can only handle up to 5 amps, and the power supply for this supplies 10 amps. So I'm not really sure that using a 5 amps rated switch would be main power switch would be a good idea. So I'm just going to have to wait, unfortunately. And and then there's the O-rings for the main pulley that I haven't gotten yet. So I mean, the main motor can't turn the spindle, which is obviously a problem for the functionality of the device. So about the electronics assembly, let's cover this stuff more in details. The instructions are very straightforward. In the end team's video, it's fairly easy to know what you need to do. Connect wires, do a tiny bit of soldering, way less than in the cable preparation. And I mean, the connections kind of speak for themselves. You take the CNC shield, you just plop it onto the Nucleo board, and voila. There is a few things though that you have to consider. So on the Nucleo board, there are two buttons. I think it's the reset button and like the is it called user? I don't know. It makes whatever it is, it makes me think of user. But there's two like buttons that have large caps that you will actually be pressing down on if you just install the V3 CNC shield, just like that. So you have to remove those plastic parts. It's really not too difficult. I've conserved them. If I guess I ever want to use the board for anything else, although I really don't think I will. But yeah, those buttons, you just remove the plastic caps and you're good to go. And then also one thing about the Nucleo is that in the for to us to like bolt the Nucleo onto the board holder frame, which is this piece here. So the Nucleo is like on the here there. I think you can see it spins. Maybe I can show it sort of. Yeah, you see like the blue and white board in there. Um, there's like two bolts that you use plastic washers on. The plastic washers they give you as printed parts, and honestly, I feel like they're not super. I mean, I feel like they're not made super well. They might, they work, but I think they could be a bit thicker because as of now, what happens is that part is only really two shells, two concentric shells with a bit of a gap in between them. And so it didn't happen to me, but it's really the type of situation where I would see the two shells just completely disassembling from one another and you're left with two parts instead of one part that doesn't really work all that well. And yeah, I mean, I understand the reason why we're using plastic washers, but maybe, since we're already sourcing all these components, maybe just sourcing plastic washers, like proper plastic washers, could be a possibility. Nevertheless, that's a very small gripe. Um, so one, the probably the biggest holdup, or the biggest like how can I say, like the step that took the longest amount of time was to trim the drivers properly. Because my drivers I got from a random a random the electronics shop where I live, and it was a bit difficult at first to find the everything for it because the electronics shop links to the data sheet of the embedded like the electrical the chip, the embedded electrical chip on the controller itself, and the controller has like a bunch of other different parts on it, resistors, capacitors, etc. And obviously, the manufacturer of the chip, they don't know what people are going to put on the board, like what value of resistances people are going to put on the board, and so they can't really specify or tell us, oh, you need to trim for this type of VREF, um, given this maximum current in the motors, because it depends on the resistors put on there, and so you have to find where are the resistors, and sometimes it varies from one manufacturer to another, then you need to find their value, which I mean the resistor, the R sense, I think they're called, they're fairly low values, and so using the multimeter was pretty hard to actually know what values they were. You actually had to read them, which I have pretty good eyes, but these things are really small. So I like double, triple, quadruple check to make sure that that was right. At the end of the day, these microcontrollers have had an R sense of zero point 0.1 ohms, which is pretty. I think it's not unusual. So there's a lot of stepper motor drivers with that R sense value. And the NEMA 18, NEMA 11s, not NEMA 18s, NEMA 11s here, they have a maximum, at least from the listing, have a maximum current of 0.67 amps. I think I trimmed it for a bit lower than that. And then there's the Z motor here, which is also a stepper motor, but is rated for a different current, which makes sense because it's way smaller. That was a bit confusing at first to know like what voltage this ran at, but from the listing, not of this motor specifically, because I got this one from eBay, but the listing of some uh, of the motor with the same name on other websites, which I mean, I didn't buy it from there because it was super expensive. Of course, obviously this part is discontinued. I got it from eBay, but from other sites you can see that this is the 4-volt version, which has a max current of zero point 0.2 amps. I don't understand how that works. I really hope that it's 4 volts going on there, uh, even if the power supply is 12 volts. But I trimmed it for zero point 0.2 amps because that's what the specifications were. Hopefully that's right. Considering that the N team is using, a certain type of NEMA 11s, which I think tend to have the same max screen capabilities, and this specific Z-axis motor. It would have been nice if they told us, the whole thing runs at this voltage, or um, you should trim for this max current depending on the drivers you have. But hey, I mean, at the end of the day, it wasn't too complicated. It was just a bit of research that was required to get this working, and everything was fine in the end. So now, yeah. So in previous videos, I said, oh yeah, the cable orientation or order of cables for motor probably doesn't matter, meaning like the order of the coils probably doesn't matter all that much. Well, in their electronics assembly video, the NT makes a point of the order in which cables are placed in the connectors. And it was quite easy for the stepper motors because I assembled them exactly like they did. And yes, the cables were reversed with respect to the arrow on the connector. But at the end of the day, you could just flip it around and you had the same order. So that was very easy. But for the Z motor, since my cable was a bit different than theirs, I actually had to do a bit more it was a lot more effort to try and get this right. Because, well, first of all, I have the cables coming off of the motor itself. Let's see, these guys here. And then I have the cables of the uh, male connector, no, the female connector, which are very short, just at between this heat shrink and that heat shrink, which are a different set of colors. And then I have the cables coming off of the male connector that go all the way up in this guy and come back and get plugged in. So every single step of the way, I had to make sure that the order was right, referencing the colors of the cables coming off of the motor. So that was a bit of a pain, but it's hopefully worked out well in the end. I made sure that the coils were placed right, but obviously I can't make sure with this multimeter that I've placed the correct coils in the correct position. I used my eyes the best I could, and hopefully when this whole thing gets powered up, when I get the final parts, everything will be fine. So yeah, so essentially we have a problem here with the main power switch. It's missing because I just don't have it. That's as simple as that. But there's more than that. There's another thing. So I haven't plugged in any power cables for now because obviously I'm missing one of the power components, so why bother? Um, but there's underneath of this stuff, on the CNC V3 shield, there's a screw terminal for power connectors. Now I know this is like fairly common, and you've kind of found you get screw terminals on many different boards for like CNC machines, 3D printers, etc. My Rostock Max V3 has a Rambo inside of it, and it's a screw terminal. Again, but the thing is, I really don't like screw terminals because I also have a Tivo Tarantula, which is in pieces, sort of right next to me as well, and it's 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 gone so wrong in so many ways just because of this ridiculous power screw terminal configuration where you take one very thick cable and like two other like thinner cables, sort of wrap them around all of them, create this massive super thick cable that is impossible to squish, and then try and plug that into a screw terminal, and it just falls off all the time because a screw terminal is super shallow and that cable is super thick, and there is no way with that tiny screw that you can apply nearly enough pressure to keep that in when it's pointing downwards. The reason why the screw terminal in the Rostock Max works really well, there's two reasons. First of all, you can remove the screw terminal and apply like good pressure on it when screwing the cable. Second of all, it doesn't point downwards, so gravity doesn't pull isn't pulling the cable downwards, which kind of helps. Also, the all the cables are concealed inside of a closed box, if you want. So there is very little chances of anything just coming around, knocking things around. That wasn't the case for the Tivo Tarantula, which is why it broke not once, not three, not two, not three, but four times. And I had to replace the board probably twice before I just gave up on this thing. And yeah, so that was a terrible experience, and I really don't want to relive this. And again, here we have screw terminals pointing downwards with potentially massive power cables. So I'm wondering if I can just crimp that to something flat and just insert the flat metal shim inside of the screw terminal. That will probably be exponentially better. I just have really bad experiences with screw terminals, and I just really hope that I don't blow anything up here, because not only are these parts sort of expensive, not as expensive as the board on the Tarantula, but they're really hard to get. I don't know why this STM32 board in particular was used, but it's just not very common. I don't know. I don't know why, but yeah, I just hope that I don't get any issues with that, because I mean, power cable stuff is can be super problematic. There's a lot of current going through there. There's a lot of power going through there, and yeah, I just hope that everything goes well on that part, and I might do some extra steps to ensure everything is as smooth as possible. Um, right. Um, so when I was wrapping this up with the spiral sheath. First of all, it was probably one of the most satisfying things in the build, just wrapping everything up into a nice little bundle here. Now you can see there's actually a second cable. I haven't wrapped it up. This one, this is for the camera, which is not shown in the videos. I don't think anywhere they do mention the camera in the new head parts videos, which I actually these are the new head parts, right? So right from the start, I had the right head parts for this, but I had the camera too. So I plugged in the camera here, and now there's the cable coming off. I don't know if I should wrap it together with this guy, because this goes to a computer, not the board. So I don't exactly know if I should wrap it together, but maybe I will. So anyways, here I started by wrapping up the three motor cables here. I think that this will be good enough so that this can go all the way to the bottom of the z-axis. And then I sort of had the other cables, so the N switch cables and the Z motor cables, sort of joined together here in the wrap. I wrapped up my ESC because it's a lot slimmer than the Afro ESC, and so I could just do this. Also, it's a lot more secure than just hit sort of flopping in the on the bottom. It makes me feel a bit better, even though it looks a bit strange. Then I just wrapped up the rest. And one thing that's very important here to see is that I exposed the two connectors we're using. So the Z-axis connector, Z-axis motor connector, obviously here is exposed. Um, because the spiral sheath isn't really getting to it yet. It actually gets to the spiral sheath much later. But also the ESC connector here, the XT30s, I ended up using. Those are also exposed so that I can unplug them if necessary. And that brings me to one concern I do have with the ESC is that I've seen people saying that these ESCs are programmed to stop very abruptly, which can damage some parts here, or actually no, which can damage some electronics on the nuclear board or wherever. I'm not super convinced by that, because I mean, you also have like these types of boards, or like you can have similar types of boards with just like RC stuff in general, and I don't think those would survive a very similar scenario if it were to damage this types of electronics. But I'll keep reading on this to see if it's fine. Like, I haven't downloaded any kind of firmware or uploaded any kind of firmware to this machine whatsoever, again because I'm missing some parts. But that's something that I may need to check on later. Then what was that? Oh yeah. One thing about the cable management, I like the parts done for cable management. There are two main parts. There's the part here at the very, oh my god, that's impossible to see. This guy here to sort of hold the Z-axis motor connector nice and tight and close to the head, which is nice. And then there's these sets of parts here, which are nice, sort of it gives a tube to place all the end switch cables and the Z-axis motor cable inside of. Nice cable management parts, but this one here is very floppy. Uh, I had to drill a lot of holes through most parts if I wanted to get a M3 bolt to go through nice and easy. But this part, I didn't drill anything and it's super floppy. So I don't know what's up with that. And I may have to change it eventually. I tried to, sort of stuff the holes with something to try and get these bolts threads that have more of an impact, sort of hold it better, but it just it comes off. The threads aren't doing anything. So I don't know what's up with that, and it's a small part, so if I want to change it, that's plenty fine. So that's essentially it for the important stuff for the electronics assembly. Like a fairly straightforward process. But there is one, actually, yeah, there's one main thing I did do is first of all in the new head, um, the new head video that the N team has posted, they talk about the new cap here, which is nice because it gives me a reason to have slightly longer rods here. So if anything, that's cool. And it doesn't look nearly as bad anymore. But also, I had to modify this top head part, which yes means I had to undo a lot of stuff and unscrew a lot of bolts to get to get this part changed up. And essentially, what I did here, first of all, is I adapted this Z motor connector or like screw hole so that it worked with my physical package of the motor, and now it's nice and tight. It doesn't like come up or anything. It's really tight in there, so we're gonna get strong force in upwards and downwards movements. Another thing is that I modified the hole for the camera because in I ordered the exact camera endoscope that the end team was suggesting in their bill of material. I think they gave a link, not in the bill of material, but in one of the videos. And I followed that link. I bought that exact camera. It wasn't too expensive. That's nice. But the thing is, uh, the diameter of this camera was 8 millimeters, and the end team says, "Oh yeah, this is a 7 millimeter camera." And they just have it shoved into their head part. So I don't know if I got sent the wrong camera or if the I don't know what happened there, but mine is 8 millimeters. There's a 7 millimeters, and I bought the exact same. So what I had to do is change this hole to be 8 millimeters instead. And essentially now after I did that, it's fine. It now goes into both holes very nicely, and I should have a nice view of the workpiece. As we go. I don't really know yet how this is implemented. I know it's used for the double-sided PCBs, which I'm very glad for because I have a large stock of blank double-sided PCBs, and I think double-sided PCBs are pretty useful instead of just single-sided. So yeah, hopefully I can use this for something pretty nice. I just don't know exactly what it's used for quite yet. It might be obvious as I keep going though. So that's that for modified parts. Actually, it's not true. Because when I actually did the bed, I realized that with this new version of the bed, um, they have this new part here that goes onto the bed holders, and to sort of uh, reference what I think the second video. So the one video after the live stream I did, I said I replaced the some parts of the bed holders so that they fit my slightly thicker half-inch board, and I had to do it again essentially here so that it fit nicely. And I mean, now once I already knew how to do it, it was pretty easy, especially considering that these step files are not broken this time around. They actually worked pretty well. So there you go. That was pretty easy to just modify these parts and print them just like that. Um, so that's it for that. The brass. Okay, so there's a bunch of these parts. So these parts here with crimps, right, have little brass foils inside of them, and then on the connector here, that can slide off. I really like this design, and there's more little brass foils you have to input inside of there. It's really annoying. It's probably one of the most annoying parts of the build just because the little patterns written in these brass tracks sometimes makes it so my at least I don't maybe my printer is just not good enough for this, but what happened is that they got way too the holes, the little tracks actually weren't thick enough so that the brass foil fit in, so I had to go in with a knife and try and like loosen them a bit, and especially when you had like um, little small indents, that was really painful. But it ended up working, and that was fine. Yeah. The thing is, once the clamps are fixed and the boards are set in, which requires me to sort of sand the side of the boards, not because I put the rails in wrong. I'm pretty sure I put the rails in just right. I used the caliper trick, and honestly, that's amazing because the screws just fall into place. Um, it's just my boards, the boards I have, actually, they're not really cut well. When you pick them up, you know that the sides have a lot of, if you want, like sort of uh, fiber flash, so there's like a significant thickness where it's just the glass fibers and there's no copper. So what I end up doing is just sanding the edges until it fit, and then when it's like just copper, it fits nicely, and there we go. Only the clamp really clamping down really well. I can't really move it at all. And if I want to retrieve this, I'm probably going to have to just remove the clamps altogether, which includes 3 bolts per clamp plus 2 bolts on the sides. So I don't know why the overkill on bolts, but sure. I haven't plugged in the probe wires um, to be there all the time. I just have them hanging out, and I have my alligator clips coming in like that. I don't know how I'll do it. I don't know if I'll actually go and try and get the. There's a little hole next to one of the bearings on the head. It doesn't have the Mochu 706C bearings. It should be conductive enough so that it could serve as a permanent probe. But for now, I'll just use the alligator clips, and if I get tired of this, then I'll just do a permanent installation. And I think that's about it. No, there's one more thing I really need to look at maybe when I start sort of get everything running is that usually when you rotate one of these guys, the head should move 45 degrees exactly. But I've noticed that when we get to this section of the rods, it sort of starts jamming up a bit and doesn't go like full 35 degrees sometimes. And so I'm thinking that it's because of some roughness on there. And so I don't know if I might have to like heat the bearings or whatever. But it's something I may be on the lookout for. It's a note I made for myself so that if ever I have problems like this, well, I know that this might be the issue. Well, that's about it for the ant build, besides, again, the 2 parts I'm missing. So I'm not going to be uploading any firmware to this thing and doing any tests whatsoever until I get the power switch and the O-rings, because, I mean, it just wouldn't work properly. But yeah, I'm fairly happy with this build. I think this little machine is very sturdy. I've seen people having a lot of fun with what this can do. A lot of issues as well. Hopefully, I avoid the issues as much as possible, and I maintain most of the fun. And yeah, I've seen this do really precise work, and I'm pretty excited to sort of do my own PCB, something that is very convenient at times, really. All right, well, I'll see you guys maybe in, let's say, like a week, I guess. I don't know when I'll receive my things, but anyways, until next time, peace out.